Hey, so this will be the last video on the basic functions. I'll come back at a later stage and add in some logs and exponentials. This is the basic function. So the way they can make this question a little bit trickier is by making you work back the way. So we just looked at questions where we were looking at how does x and y change, and like we said, if the k is inside this bracket, it affects x. If it's outside the bracket, it affects y. So this is saying that we're timesing by y, and then we're adding on to the y. Anything inside the x would do the opposite. So now we know, right? I've got f of x. Let's see if it does it. I've got a function f of x. I've also got a function af of x plus a. So here, my original um, coordinates are on this line. So it's 0, 0, and 2, negative 1. So I've got 0, 0, and a 2, negative 1. And somehow that's become these new coordinates. I've got 0, 3, and 2, 5. Well, the first thing we're looking at it, I'd be saying to myself, well, it's definitely been flipped. So we've times by negative, that's for sure. And then it's been moved, hasn't it? Because even times by negative, if this was purely just a times by negative, I would have expected it to do something like this, because then that would, excuse my terrible drawing, it would completely, really, really got off the edge there. Uh, you know what I mean? It would completely mirror along the x-axis um, this line. So it's done that. It's been times by negative 1 at the very minimum, and then it's been moved up. So what's a way we can actually work out exactly what's happened here? Well, this is a nice clue. The 0, 0 is unaffected, isn't it, by what's happening with the reflection. That's just been moved, hasn't it? That's just been moved up 3. So I know that, well, wait a minute, if that was negative 1 in there, that's been moved up 3. So I'm thinking y's definitely been moved up by, get from here to here, there's been a plus 3, hasn't there? Because even if I times as a 0, 0, if I was timesing it by any number, like k, it doesn't affect that. So that's been moved up by 3. So this has also been moved up by 3, but if you were to add 3 onto that, you get 2. You're thinking, okay, well, that's because it's been multiplied by something as well. So let's try and think of a wee equation for this. We could say, okay, did it k multiplied by negative 1, because that's the initial value. Add 3 is going to give me 5. So we'll work back the way. We'll say, okay, k times negative 1, so that'll be negative k, is equal to 2 if I take away 3 from this. So that means that k has to be equal to 2. Let's see if that makes sense. The negative 1 times 2, so I was times that by 2. Sorry, so negative k is equal to negative 2, sorry. Times that by negative 2, that's going to give me a 2. And then would I have to add on to 2 to get to that? Yes, I have to add on plus 3. So you might instinctively just have kind of thought it was a negative and then said, well, I'll try negative 1, 2, 3 or whatever. But if you want to try and do it with a wee bit of algebra, oops, that's what you're thinking. Got your little equation, your two-step equation from first year effectively. K times this y value, add 3 is going to give me 5. So k must have been negative 2, because negative 2 times negative 1 is 2, plus 3 is 5. So I know that I know that a is going to be equal to 3. I know that k is going to be equal to negative 2. So there's a wee bit of intuition, I think, on these, but you can break it down into what is effectively two-step equations from first year as well. So yeah, let's go on to the next one. Yeah, it's just a wee bit trickier though, isn't it? It's just a little bit, it just requires a tiny bit more intuition. So this one, we've got the diagram of this. So again, it's our change diagram, work out the original diagram. So before I used to always do x and y, which were my original coordinates. That's what we're trying to find. And then I'd put x and y, which were the coordinates that I knew. So I know I've got x is 6 and y is 4. Now what's happened to my original as well? For y, I've taken away 3. So for x and y, y has been taken away 3. And x is 2x, so that means it's divided by 2. It's the opposite inside the bracket. Divided by 2. We're just going back the way. This is like a two-step equation, isn't it? So for y, I'm saying, okay, for y, if I do y take away 3 equals 4, what's y going to give me? That'll be 7, won't it? Going back the way. This one is saying x divided by 2 equals 6. X is equal to 12. That means my original value was 12, 7. Just write that as a little coordinate as well. The final answer, 12 is 7. So think about it logically. Take your time. Don't stress out. Just remember, stuff inside the bracket affects x. Outside the bracket affects y. On, hopefully. Here we go. Incredibly, no, maybe not. There we go. And the very last one we're going to do is this one. And I quite like this one because it's got the dashed in it as well. And I like the way they've written this to try and confuse you. Okay, so in separate diagrams, sketch these. So first of all, let's remember that this is y is equal to negative h of x plus 2. Just rewritten it a different way because it looks nicer. But really, it's just that. So let's write our original coordinates out, x and y. So I know I've got this one here. So I know I've got, what's that, 0, 5. I know I've got 2, 2. 2, 2 still makes me laugh. Whether it's for the... Let me see, I think of Desmond 2, 2. Yeah, anyway, 2, 2, and then I've got these 2 points here. We don't know what the x is on them, but we know the y is 0. So I don't know, but I know the y is 0. Don't know y is 0. It's worth just pointing out because when we reflect it, we're still going to go through those points, aren't we? So what's happening to the x and what's happening to the y? Well, x, nothing. Nothing next to x. For the y, times them by -1, and then adding on to a. So 0, 5, that's going to become, well, sorry, that's going to stay the same. And I don't know what's going to happen. Sorry, that's going to still stay the same. So that's still what these question marks. So we're going through those points. But for the y, that's a -5 plus 2. So that'll be -3. 2 times that on -2 is going to come as 0. And these ones here, again, times them by -1, it's going to become 2. And we're just going to move up to. So let's see if we can draw that on. Pardon me. So it's purely just an invert. It would look something like that, wouldn't it? Through here down to 5, and something like this. That was a purely inverted drawing. But now we're having to move it up 2 as well. So that's going to sit here. That's going to sit up there. That's going to sit just on the axis, isn't it? Yeah. So we'll do something like that. So 0, -3. See, so that's 0, -3 in there. I said this was my kind of question mark, wasn't it? That's gone up to 2, and that one gone up as well. Those are my little question mark numbers, just to kind of give you an idea of the sketch. And this one here has become 2, 0, bang on there. And then I could just draw it, and I'll draw this one in blue. It's doing something like that. Yeah, something like that. Yeah, just take your time. I think that's the main message, is just take your time. You can even just try and imagine it in your head, do it in stages as well for the sketch. You don't have to draw next to this sketch, so that makes your life a tiny bit easier, and make sure you label up your point as well. But yeah, write down your original, what you do into the graph, and change it. And the last one is the h dash x, so I'll just do this over this side. I'll do it below it very quickly. The most important thing to remember here is this is no longer y, it's dy by dx. So when is dy by dx 0? Well, it's stationary points. There's a stationary point, and there's a stationary point. So these 2 points, yep, across the axis. Here we see we've got a positive gradient, then a negative, then a negative. So I've got a positive gradient, that must be in here, got a negative gradient, and then after that, it must be another negative gradient. I'm going to get cut off soon. So it must do something like that. So I'm going to cut off soon. Have a look at the differentiation videos for that. But yeah, they might try and tie it in here. Thanks.